If you've ever felt out of the loop at work or found yourself blindsided by something you should have known, don't worry. You're clearly not the only one. Because while many people all over the world were glued to headlines about the mysteriously speedy interstellar visitor 3I/Atlas, another cosmic guest managed to slip by practically unnoticed. In fact, this second asteroid not only approached Earth, but did so at an incredibly close distance, making a flyby that should have had scientists, news outlets, and the general public buzzing. Yet somehow, on Wednesday, October 1st, astronomers across the globe failed to spot it until it had already made one of the closest passes to Earth ever recorded. The asteroid, named 2025 TF, approached our planet in near silence, sneaking by just 260 miles above Antarctica. An astonishingly short distance in astronomical terms. To put that into perspective, the International Space Station orbits Earth at roughly the same altitude, about 260 miles up. So this wasn't just a near miss in the usual sense. This was practically a neighbor knocking at our cosmic front door. Imagine a space rock roughly the size of a small car passing by at the height commercial airplanes travel, except traveling at an unimaginable speed of 46,000 miles per hour. That's like sprinting past someone so fast they don't even realize you were there. It's similar to hearing a knock at the door, getting up to answer it, and realizing the culprit has already run halfway down the street, except instead of a mischievous kid playing ding-dong ditch, it's a chunk of space debris hurtling faster than a bullet. For comparison, the closest asteroid ever observed passing Earth was 2020 VD4, which skimmed by at just 230 miles above the planet's surface on November 13, 2020. Even that encounter was detected only hours after it had passed. And now, 2025 TF has claimed the second-place spot on that list, joining a growing catalog of asteroids that arrive unannounced, slip by our detection systems, and leave scientists scrambling to piece together the exact details after the fact. What makes the story even more intriguing is that the asteroid wasn't noticed until after it had already reached its closest point to Earth. The discovery came from the Kitt-Peak Observatory in Arizona at 6:36 Universal Time, coordinated on October 1st, less than 6 hours after 2025 TF's closest approach. By the time the observatory detected it, the asteroid was already racing away from our planet on its continued orbit around the Sun. It raises the question, how does something that close, that fast, and that potentially dangerous slip by unnoticed until it's practically out of sight? Astronomers, of course, have explanations for this. Many of the smaller near-Earth asteroids are notoriously difficult to detect. They're dark, non-reflective, and often approach from angles hidden by the sun's glare. Telescopes can't see everything at all times, especially when dealing with smaller objects that don't reflect much light until they are almost directly overhead. In this particular case, 2025 TF came from a direction that is more challenging for Earth-based observatories to monitor, which contributed to the delayed detection. But still, it's a reminder of just how vast, dynamic, and unpredictable our cosmic surroundings are. No matter how advanced our technology becomes, space finds a way to surprise us. What happened next was a flurry of activity from astronomers around the world who hurried to confirm the asteroid's trajectory and characteristics. Among them was amateur astronomer Philip Romanoff, who posted on X, formerly Twitter, on October 2nd that he had successfully observed the asteroid remotely using the Liverpool telescope, operated by Liverpool John Moores University's Astrophysics Research Institute in the UK. Romanoff even shared a photo of the asteroid, small, faint, and streaking through the background of distant stars. His observation helped confirm that 2025 TF was real, documented, and on a verifiable path through the solar system. It also highlighted the important role amateur astronomers play in tracking near-Earth objects. Sometimes, it's not massive observatories or billion-dollar equipment that catch the action first. It's passionate individuals with access to remote telescopes and a dedication to watching the skies. 2025 TF belongs to the Apollo asteroid group, one of the largest families of near-Earth asteroids known to astronomers. Apollo asteroids have orbits that cross Earth's path, meaning they can occasionally come dangerously close to us. While most of these objects never pose a direct threat, their unpredictable orbits and frequent encounters with Earth's vicinity make them important to track. The Apollo group includes thousands of known asteroids, with many more likely undiscovered. These objects can sometimes slip into Earth's neighborhood without warning, just like 2025 TF. As for its future path, astronomers believe 2025 TF is currently moving inward toward Venus's orbit, and from there it will eventually swing outward beyond Mars. This path is fairly typical for an Apollo object, whose elongated orbits carry them through different regions of the inner solar system. They weave between planets, repeatedly circling the Sun, sometimes approaching Earth, and sometimes drifting far away. Because of these orbital patterns, they remain under close watch, not only for scientific curiosity, but also for planetary defense. But perhaps the most unsettling part of the whole event is the reminder of how vulnerable we truly are when it comes to detecting smaller, but still potentially dangerous space rocks. An asteroid the size of 2025 TF wouldn't cause worldwide devastation, but if it entered Earth's atmosphere, it could create a powerful airburst similar to the Chelyabinsk event in 2013, where a 60-foot asteroid exploded over Russia, injuring more than 1,500 people with its shockwave. A small asteroid at the right angle can shatter windows, cause fires, or create dangerous debris strikes. Luckily, 2025 TF continued on its way harmlessly, but it serves as a powerful reminder that Earth is not immune to surprise visitors. For now, scientists are taking this close pass as an opportunity to learn more about how detection systems can be improved. Better surveys, more advanced telescopes, and expanded early warning systems could help catch similar objects long before they arrive. Many initiatives, such as NASA's planned NEO Surveyor mission, aim to identify threats while they're still millions of miles away, not hundreds. But until those tools are fully deployed, we remain dependent on existing observatories and dedicated astronomers to keep their eyes on the sky. In the end, the story of 2025 TF is a blend of surprise, scientific curiosity, and a bit of cosmic humility. It's a reminder that even with all our advancements in space observation, the universe is full of mysteries that can appear without warning. A small car-sized rock traveling at tens of thousands of miles per hour, silently brushing past our planet, is both awe-inspiring and slightly unsettling. It shows how much we still have to learn and how closely connected we are to the vast expanse of space around us. And while it's easy to get caught up in daily routines, workplace drama, and the endless stream of news about distant stars and far-flung galaxies, moments like this bring the reality of the cosmos right to our doorstep, sometimes within just a few hundred miles of it. The universe is immense, unpredictable, and endlessly fascinating, and sometimes it sends us reminders in the form of silent visitors who pass by without a sound, leaving us to discover them only after they have already come and gone.